Hello again to another Agakale Reacts, and today we will be watching how the Tonga Volcano Eruption will cool the Earth from Everything Science. Let's just see how's that gonna happen and...
Well, a tsunami has hit the island nation of Tonga.
Take a look at this satellite video.
Breaking news. A tsunami advisory is now in effect for the entire U.S. West Coast and Alaska.
It's a very large explosive part of this eruption.
Saturday, January 15th at 5:15 p.m. local time, a volcano on the island of Tonga erupted, sending a 5-kilometer wide cloud of ash 20 kilometers into the atmosphere. Now, Tonga is pretty much never included on maps, but if it was, it would be a few hundred miles northeast of New Zealand. Loud explosions could be heard on islands up to 65 kilometers away. From space, the erupting column of smoke and even atmospheric shockwaves were captured propagating across the Pacific Ocean. The eruption started a magnitude 5.8 earthquake, and a tsunami that reached as far as the United States, although by the time it got there, waves were limited to only about 4 feet. But the Tonga explosion will have far more reaching consequences than what's happened in the immediate aftermath. Preliminary observations showed the eruption ejected a large amount of volcanic material into the stratosphere, enough to cool the Earth, and, at least temporarily, reverse man-made climate change. Get ready for some extreme ice storms over the next few years, and if you live in Florida, you might want to buy your snow parkas now. When an eruption happens, hundreds of millions of tons of ash can be flung high into the stratosphere. These particles reflect sunlight and cause temporary cooling. Larger particles of ash have little effect because they fall out of the air almost instantly. Standing near a volcano, they can make it feel like you're being pelleted by raining pebbles. Medium-sized ash particles of about 2 millimeters, the thickness of 2 credit cards stacked on top of each other, form a dark cloud in the sky that shades and cools the areas directly beneath it. This is what makes up the majority of the great volcanic plume you can see here. Most of these particles are pushed out of the atmosphere by rain within a few days of an eruption, but the smallest particles of dust, those the size of human hairs, get into the stratosphere and are able to travel vast distances, often worldwide. These tiny particles are so light that they can stay in the stratosphere for years, reflecting sunlight back into the air and causing cooling over large areas of the Earth. At the same time, erupting volcanoes emit sulfur dioxide. Sulfur dioxide is much more effective than ash at cooling the climate. The sulfur dioxide combines with water to form sulfuric acid, which makes a haze of tiny droplets in the stratosphere that reflect incoming solar radiation. These droplets can stay in the stratosphere for years, spread around the globe by wind, and causing significant cooling worldwide. If you're interested in learning more about this, we made an entire video about how some scientists want to fight climate change by injecting sulfur dioxide high into the Earth's atmosphere. Give that video a watch after this one. The Tonga explosion has been estimated to have a VEI of 5. VEI, or Volcanic Explosivity Index, is a scale for measuring the explosivity of an eruption, in the same way the Richter scale measures the severity of earthquakes.
What's the scale?
VEI works
5?
on the logarithmic scale. Every 1 point increase in VEI is a 10 times more powerful explosion. So the difference between a VEI of a 4 and a 5 is a 10 times more powerful eruption, and the difference between a 4 and a 6 is a 100-fold increase. To help put this number in context, let's look back at some eruptions from history. The largest volcanic eruption in recorded human history was the 1815 eruption of Mount Tambora. The eruption pumped 150 cubic kilometers, roughly 36 cubic miles of ash, and some 55 million tons of sulfur dioxide gas more than 20 miles into the sky. Today, humans worldwide emit 26 million tons of SO2 from burning coal, fossil fuels, engine exhaust, and other sources annually. So this was about 2 years worth of modern-day SO2 emissions put into the atmosphere in the course of only a few days. The eruption led to global cooling and worldwide harvest failures, and would come to be known as the year without summer. While the explosion only, and we're using the word only very loosely, killed 100,000 people directly, the mass famines it caused would indirectly lead to millions more deaths around the world. Only a few hundred miles away in the same archipelago, the 1887 eruption of Krakatoa had a VEI of 6 and caused global temperatures to fall by 1.2 degrees Celsius on average. While that might not sound like a lot, remember the global goal on climate change is to prevent only 2 degrees Celsius of warming, so an eruption on this scale would accomplish more than half our goal today. In 1784, the smaller Laki volcano eruption, at a VEI of 4, released enormous amounts of sulfur dioxide, killed a quarter of the Icelandic population, and caused northern hemisphere temperatures to drop by about 1 degree Celsius the following year. And this was for an eruption about 10% the size of the one we just saw. Notice how we have to go back hundreds of years to show equivalent eruptions? Well, that's because eruptions on this scale are quite rare. Since 1800, there have only been 20 volcanoes with a VEI of 5 or higher, about one every decade. On average, these eruptions lowered global temperatures by about 0.4 degrees Celsius for an average of 6 years until temperatures returned to normal. After being relatively inactive since 2014, the Tonga volcano erupted on December 20th, 2021, less than a month ago. Over the next few weeks, as activity on the island decreased, the volcano was declared dormant on January 11th, 2022, just 4 days before it would produce the largest volcanic explosion of at least the last 20 years. No matter how much you've screwed up at your job, rest assured, you didn't tell the world everything was safe, days before half your island was obliterated. That's pretty much on par with this tweet from the World Health Organization. It's important to know that not all volcanoes of a given VEI have the same effect. The 3 factors that have a big impact on how much an eruption cools global temperatures are the distance to the equator, the chemistry of the volcano, and how high the volcanic plume reaches into the atmosphere. The Tonga eruption is poised to go 3 for 3 in these categories. The eruption in Krakatoa we mentioned earlier had a latitude just 6 degrees south of the equator and cooled the Earth by 1.2 degrees Celsius. But the Nova Raptor explosion in Alaska, at 60 degrees north of the equator, had the same VEI rating of 6, but cooled the Earth by less than a fifth that amount. Tonga, at 21 degrees south of the equator, is a medium distance away, but the Coriolis effect makes up for this distance. In the southern hemisphere, currents are deflected to the left. As a result, air systems seem to rotate clockwise. On the day of the eruption, and immediately following it, Tonga was pitched in the middle of 3 swirling air pockets. By far the largest of these was to its south. This means warm air from Tonga, containing millions of tons of ash and SO2, was pulled south, where it spiraled with colder air from Antarctica. Since warm air rises, this quickly pushed all the ash and SO2 from the eruption high into the atmosphere. Moving on to factor 2. The effect of eruptions on cooling also depends on the chemistry of the volcano. Since SO2 is much more effective at cooling the Earth compared to ash, the more SO2 the volcano emits, the more it will cool the planet. The Tonga eruption was underwater, and since water is incredibly good at absorbing SO2, we likely won't have estimates for how much SO2 was released for weeks, if not months. But other volcanoes in this part of the world are amongst the highest sulfur dioxide emitters, meaning it's a safe bet that more than 10 million tons of SO2, 6 months worth of human emissions, were just emitted into the atmosphere in a matter of hours. Finally, subsequent cooling is also dependent on how high the volcanic plume reaches into the atmosphere. The higher it goes, the more fine particles reach stratospheric levels, where they can remain airborne for years. Satellite imagery of the Tonga eruption shows the ash cloud reached an altitude of 20 kilometers into the atmosphere, much higher than the Krakatoa eruption, which only reached an estimated 6 kilometers and still caused 1.2 degrees of cooling. Today the Earth is about 1 degree Celsius warmer than pre-industrial revolution averages. Earth's temperature rises by an average of 0.18 degrees Celsius or 0.32 degrees Fahrenheit every decade. Based on prior volcanic eruptions, over the next 5 years, the Tonga eruption will lead to at least a ½ degree Celsius reduction in global temperatures. In effect, temporarily turning back the global clock 2 decades. Maybe we'll finally have some good ski weather. It's important to realize this isn't a long-term solution. In fact, it's not even really a short-term solution. Over the next few years, as fine ash and SO2 drop back out of the upper atmosphere, the Earth's warming will reset back on its original path. But perhaps the Tonga eruption can be a modern-day trial of how SO2 released high into the atmosphere affects global climate. Maybe one day, as temperatures continue to climb, humanity will begin purposely injecting SO2 high into the atmosphere. Check out how we could do that in this video here. And remember, there is always more to learn.
It's true, there is. I kind of forgot about that eruption. I remember I was watching stuff when it happened. That was only more than almost 2 years ago, but still, it's not that long ago. And, well, we shall see what's gonna happen. It's all kind of long-term predictions, isn't it? That's what it is. Okay, thank you very much for watching. I'll see you tomorrow. Bye!